All right, greetings. Okay, let's determine the mechanical work done to lift where the mass is 77 kilograms, and we're going to lift it. The distance is equal to 2.5 meters. Okay, mechanical work is defined as this. It is defined as the work is equal to the force times the distance. You probably learned that in junior high science. Okay, force times the work equals force times distance. There's a key to it though, is it's the force that's in the same, you're either pushing a force this way and it's changing the distance this way, or it could be an object could be changing the distance this way. The distance could be changing this way, but the force is working against it. In other words, it's slowing it down. This is work being done on the object that would be slowing it down because the force is going against it. Or if I lift something up in the air, up in the air, I'm exerting a force. My big muscles are exerting a force that's going up. Gravity is exerting the same force as going down. Because I would do no work at all in the International Space Station because there's no gravity. I could just toss that thing up in the air, no problem, and it would just keep going, bounce off the ceiling, everything else. So my muscles are pushing it up with 7.5, and we'll get to the total work in the system too in a minute. But let's just look at the work done on the barbells. Work done on the barbells. Okay, all that means, okay, so the work done on the barbells is equal to force going up and the distance that it went. And that's all in the same direction. Notice that the distance, the change in distance is equal to this. This is zero distance. This is 2.5 meters. Okay, and this is the force of, now, is the force 77 kilograms? No, the force is actually equal because we're raising it up with the same, I'm not going to get into it because your eyes would glass over and all of a sudden this video would go on to be about 15 minutes long. We're just going to say, I've got to lift the weight. I've got to lift the weight of the thing. So the force is going to equal the weight of this thing. We already learned in chapter 1 that something with, you can have mass, but if there's no gravity pulling on you, you have no weight. Force is equal to the weight times the distance. Well, what's the weight equal? Oh, that's the work. Is equal to the weight. Well, weight is equal to mass times gravity. So we've got 77 kilograms times 9.8 meters per second squared, which is our acceleration due to gravity. Put those two things together, we get 77. I'll go ahead and put this down here so you might be able to see it. 77 times 9.8 equals 755 newtons. That's our units for force. 755 newtons after Sir Isaac, good old Sir Isaac. Okay, and then so the work done is equal to this force times the distance that I raised it, and that would equal times 2.5. Boom. 1887.5 joules. That's the work done. All right? That's what that looks like. Let's take a picture of it before I put it away. This is what we do. All right.